Welcome to the Planet of Maths channel. In today's episode, we will be discussing the properties of logarithms, meaning we will be learning how to solve examples like these here. For this, we will need these three formulas. In example A, we will use this first formula. This first formula says that if we have the same logarithm bases, here's the letter A and here's the letter A, and we have to add the logs together, as a result, we will also get a log base A, except that these logarithmized numbers x and y need to be multiplied together. How will it work in this first example? Here we have a log base of 12, and we also have a log base of 12. Therefore, the result will also be a log base of 12. And according to our formula, numbers to be logarithmized, that is the 3 and 4, we now need to multiply them. And if we multiply them, we get a result of 12. We write this result here. And now, we just need to calculate this log normally. Log base 12 of 12 equals 1, because 12 to the power of 1 gives the result of 12. In example B, similarly, we have addition of two logarithms. Here is a log base of 6, and here is a log base of 6. So the result will also be a log base of 6. And the logarithmized numbers, which is 2 and 18, we have to multiply them. When we multiply them, we get the result of 36. We can already calculate such a log. The log base 6 of 36 equals 2, because 6 to the power of 2 gives the result of 36. In example C, we have subtraction of the logs. So here we will be using this second formula. If we have two identical logarithms with the same bases, here is the base A, and here is the base A, and we subtract these logarithms, the result will also be a logarithm with a base of A. We just need to divide these logarithmized numbers. Divide this x and this y. In our case, it will go like this. We have subtraction. The bases of the logs are 4 and 4, so the result will also be a log base of 4. According to the second formula, if there is subtraction of the logs, then the logarithmized numbers, that is 20 and 5, we need to divide them. So we divide 20 by 5 and get the result 4 out of this. The result of such a log is 1, because 4 to the power of 1 gives the result of 4. In example D, we have subtraction of the logs. There is 4 here, and there is 4 here. So as a result, we will definitely have a log base of 4. And since we have to subtract these logs, we have to divide the logarithmized numbers, that is 48 and 3. 48 divided by 3 is 16. And finally, we calculate this log. This log is equal to 2. Because this 4 raised to the power of 2, that is 4 times 4, which is 16. In example E, we can't see what are the bases of this logs, but we should know that the default here are 10s. There's a 10, and there's a 10. And we subtract these logs. So the result will be a log with an invisible base of 10, and if the logs are subtracted, the number 200, and this number 2, we need to divide them. 200 divided by 2 is 100. The result of this logarithm is 2, because this invisible 10, raised to the second power, gives us a result of 100. In the next three examples, we will use this third formula. This third formula tells us that if we have some number in front of the log, that is the number, it needs to jump in here to the exponent of the logarithmized number. In our example F, we have the number 2 in front, and here is the log base 4 of 8. As a result, we will have only this log without the 2, and this 2 has to jump to the exponent of the number 8 from here. The 2 from here jumps to the exponent of the logarithmized number. Then you have to do the exponentiation. The log base 4 doesn't change. We only calculate 8 to the power of 2, which is 64. And we have to calculate the log base 4 of number 64, and it is 3, because 4 to the power of 3 results in 64. In example G, we have a 2 in front, so we write this log, but without this 2 in front. And this 2 jumps into the exponent of the number 5. It is 5 to the power of 2, and you have to calculate that power. The log base 25 doesn't change, and we calculate 5 to the power of 2, which is 25. And from such a log, we get the result 1, because 25 to the power of 1 is 25. In the example H, we have a number at the front again. It is a negative number 3. As a result, we get the log base 8 of 4, but raised to the power we had here at the front. That is 4 raised to the power of negative 3. We rewrite the log base 8 and raise 4 to the power of negative 3. If there is a negative exponent, then a fraction must appear here. At the top is 1, and at the bottom is 4 to this power, but without a minus, meaning 4 to the power of 3. Now we exponentiate. 4 to the power of 3 is 64. And now, such a log base of 8, if we raised 8 to the power of 2, we would normally get 64, but we want to have 1 over 64. So we will raise it not to the second power, but to the power of negative 2. When you raise 8 to the power of negative 2, it means it's 1 over 8 to the power of 2, which is exactly 1 over 64. And finally, a series of examples where we need to combine all these properties. We have subtraction of the logs. There is 3 here, and there is 3 here, but we will not divide this at the beginning. At first, we just need to take care of this 2. Let's rewrite this log base 3 of 6, but without this 2. And this 2 from here will migrate to our exponent of the number 6. So it will be 6 to the power of 2. I write the rest without any changes. And now we need to exponentiate. 6 to the power of 2 is 36. Now we use the property that when we subtract logs of this same bases, those numbers being logarithmized, 36 and 4, we need to divide these numbers, so we will get a log base of 3, and here we will enter the result of dividing 36 by 4, which is 9. And finally, the result of the log will be 2, because 3 to the second power gives us the result 9. In example J, we act identically. We take a log base of 5, and we have to move this 3 to the exponent of the number 10, so it will be 10 to the third power. The rest stays the same. Now we raise the number 10 to the power of 3. And from this power comes out 1,000. Next is the subtraction of logs, so the logarithmized numbers 1,000 and 8, we need to divide them. The log base of 5 does not change, and 1,000 divided by 8 is 125. So the result from such a log will be 3, because 5 to the power of 3 is precisely 125. In example K, we have the number 4 in front, and in the second log, we have the number 2 in front. So first, we need to take care of these numbers. It will go like this. The log base 12 of 2, but 2 must be to the power of it. This 4 jumps over here, and we get 2 to the fourth power from it, plus log base 12 of 3, but the 2 from here jumps to the exponent of the number 3. Here we get 3 to the power of 2. And now we need to exponentiate. 2 to the fourth power will be 16. And 3 squared will be 9. Since we have logs addition, the bases of the logs are the same, so we will get a log base of 12. And we need to multiply the numbers 16 and 9. This results in 144. And finally, we can do the last operation. This log will be equal to 2, because 12 to the power of 2 is 12 times 12, which is 144. Next example, L1 example. We have the number 3 in front here. We also have the number 3 in front here, so we first deal with these 3's. Log base 10, here we have an invisible 10 of the number 2, but 2 to the power of what was in front here. 2 to the power of 3 must be here. Plus log base 10 of 5, but 5 must be to the power of that, which this number in front of us told us that's to the power of 3. Now we have to exponentiate this and exponentiate this. 2 to the power of 3 is 8. 5 to the power of 3 is 5 times 5, which is 25, and times 5 is 125. Now we have the addition of the logs. Both logs have the same bases, so these numbers 8 and 125, we need to multiply them. And 8 times 125 is exactly 1,000. And from such a log, we will get the result 3, because this invisible 10 here, raised to the power of 3, gives a result of 1,000. This example can also be done a bit differently. Since I have a 3 here and here, it's worth to factor out this number 3. Then we get something like this. If 3 goes before the bracket, we'll be left with the log base 10 of 2 plus the log base 10 of 5 in the brackets. Then this 3 from the bracket will not change for the time being, and in the bracket, we have the addition of the logs of the same bases. So we can multiply these two numbers together, 2 and 5. We then get the log based on the invisible 10 of the number 10. And this log base 10 of the number 10 is exactly 1. We multiply 3 by 1 and get the result 3. So the same result as in the previous method. And as you can see, There isn't always just one method to solve problems. Here we use the factoring out, and it's a very important activity worth knowing how it works. And that's all for this video. Thank you for watching, and I invite you to tune in for the next episodes on the Planet of Maths channel.